So we left off just a few minutes ago in the middle of preparing the data plane, and that's what we're going to continue on with here. Now, we talked about virtual switches, we talked about VDS, we talked about transport zones and transport nodes and all that in the previous video. Here we're kicking off with uplinks and lags and physical NICs and how they're all going to come together. And really, when we think about NSX, right? NSX looks at the virtual switch, whether it's a VDS, whether it's an NSX virtual distributed switch, either way, looks at a distributed switch just the same way vCenter does, where it understands that it doesn't know what the individual NICs are going to be on a particular hypervisor. So when we're configuring up a transport node in NSX, we have to think about uplinks. Uplinks are just how we're going to connect, an abstraction rather of how we're going to connect our physical NICs to the NSX virtual switch, to the host switch. And so we've got these uplink constructs on our virtual switch, on our NSX configuration. And those are going to either be mapped to lags or link aggregation groups, or they'll be mapped to individual physical NICs on the hypervisor, right? And so that's how these all come together. When we think about this, if you're coming to NSX from a vSphere background, right, what we're talking about here is really no different than what we look at with a vSphere distributed switch, right, where the VDS has uplinks and the uplinks get mapped to a physical NIC or to a link aggregation group. Here, we're just taking that one layer out from that and looking at that from the NSX perspective. My NVDS, my host switch, it has some number of uplinks, and those uplinks are going to be mapped to a physical NIC or a link aggregation group. Now, how do I know how many of those uplinks we're going to configure? Well, that's all in the uplink profile, right? So the uplink profile is a configuration template for NSX to apply that's going to define the number of the uplinks, what we're naming, what we're calling those uplinks in NSX, what our NIC teaming policy is going to be for those uplinks. In other words, how is NSX going to work with multiple uplinks? Are we going to do an active-active or an active standby configuration? If it's active-active, how do we know what traffic is using one uplink versus another, and so on? And then it's going to include things like, what's my transport VLAN? In other words, when I send overlay traffic, what VLAN am I going to send overlay traffic across? And maybe even the MTU. Now, the MTU of the uplinks, that's necessary for platforms that are not using the VDS. In other words, the MTU of the uplinks is going to be is something I'm going to configure on my edge transport nodes and my bare metal transport nodes. Right? On my ESXi transport nodes, I'm not going to configure any MTU in the uplink profile here in NSX because we're simply going to inherit the MTU configured on the distributed switch in vCenter. So there's some nuance to the uplink profile, and because of that, I'm probably going to have different uplink profiles for different types of transport nodes. Now, we do have a number of default uplink profiles, and I may use some of these and I may not, but we can go and look at these, and we have all of these different default things in NSX. Something to remember about all of the default constructs that we've built is that they're not editable. I cannot change any of these default uplink profiles, and so I can't just look at one and say, well, I like that, I want to use that, except for maybe this one thing, maybe the transport VLAN, because the transport VLAN on all of these defaults is 0 or no VLAN. I can look at these defaults under my uplink profiles under system, and we can see what we want to use, or I can create new uplink profiles here and configure them as I believe to be necessary. Now, in the uplink profile, I'm going to define a teaming policy. The teaming policy could be considered or configured rather, not considered, but configured as active-active, or what we call failover order, or Failover order would be active standby, wouldn't it? Let me make sure all my words are in the right place here. Failover order would be our active standby configuration. And then active. Well, that could be either load balance source, right? The source virtual switch port ID, or load balance source MAC using the source MAC address of the virtual machine. Now, my active NIC teaming, they're going to choose one uplink or another for my traffic, for traffic from a given virtual machine based on some characteristic of that virtual machine, either the virtual switch port ID or the source MAC address of that virtual machine. And that's how we're going to distribute the load across multiple active uplinks. Now, configuring those would be configured in the uplink profile as well. And so here we kind of see the uplink profile configuration window. If I were to create a new uplink profile, we can see in the teaming, right, I can create NIC teaming options, and I can have my default option, and then should I need them, I could create additional NIC teaming options. For a lot of cases, we're not going to worry about that. We can just leave the default NIC teaming as it is, and or just rather the default NIC teaming, and just run with that instead of creating additionals. Now, I may choose to configure my NSX host switch to send information through Link Layer Discovery Protocol, or LLDP, so that my upstream switches can have some kind of a topology, some topology information from NSX about the host switches. Well, on the ESXi hosts, I'm going to do that in vCenter. For bare metal servers and for NSX Edge transport nodes, that LLDP information would be configured as I prepare the transport node, as I assign that information to the transport node itself. But on ESXi hosts, I'm going to configure that LLDP, that discovery protocol configuration through the vSphere distributed switch config, not through NSX, through vCenter, right? So I'll manage that just like I always have with my distributed switch. Now, I can create individual transport nodes. I can define individual transport nodes. But if I've got clusters of hypervisors in vCenter, I probably don't want to build those out one at a time. I probably want to build out a cluster at a time, right? I want to prepare cluster 1 for NSX and then prepare cluster 2 for NSX and so on. And I'm going to do that not with individual uplink profiles, but with what we call a transport node profile. And a transport node profile will include an uplink profile. It'll also include a host switch configuration and IP address assignment from, say, what IP pool are we going to use, for example. It's going to define how we're going to map VDS uplinks to NSX uplinks and things like that. And it's going to basically be a template, right? A transport node profile is just an NSX configuration template for a given hypervisor or for a given cluster of hypervisors. And we want to use a transport node profile because that's going to make my configuration that much quicker to deal with. It's gonna be that much more repeatable. It's going to be that much more consistent and reusable. Right? We're going to use transport node profiles for much the same reason we would use maybe host profiles in vCenter for my cluster host configurations. Now, what do we need to build a transport node profile? We need to think about this because we're going to be building at least one of these for our vSphere cluster, maybe multiples. Maybe I'll have one transport node profile per cluster because maybe my clusters are just that different. I'm going to need my vCenter server attached to NSX. I'm going to need my hypervisors to be organized in cluster objects on that vCenter server. I'm going to need a transport zone. I'm going to need IP address pools, or perhaps a DHCP server. That's an option for my tunnel endpoint addressing as well. So we've got a number of requirements here before we can move forward with leveraging transport node profiles. Now, building out a transport node profile, this looks a lot like building out an individual transport node in that we're creating or defining the host switch configuration, what VDS we're going to use, what transport zones we're going to be a member of, how we're going to assign the IP addresses to the tunnel endpoints, what VDS uplinks we're going to use to map to what NSX uplinks, and things of that nature. Then to use the transport node profile, I simply, under the System tab, under Fabric, I select Nodes, and under Host Transport Nodes, I select a vSphere cluster. I do not select individual ESXi hosts. I need to select simply a cluster here, and I can hit the Configure NSX button, and that presents me with a very simple dialog box. It's a drop-down menu that says, please select the transport node profile. I can choose my transport node profile, click the Apply button, and that's going to then install NSX on all of the members of that cluster and apply this specific transport node profile or configuration to that cluster. Once it's all said and done, and this will take a few minutes, maybe more than that, depending on how many hypervisors are in your cluster. Here we only have 2. But if we expand that cluster object out here in the NSX UI, we can see after we go through all of the installing and configuring statuses that our end configuration result should be that we've been successfully configured and that our transport node status is up. If we click the little information icon next to the status of up, that gives us information about our network adapter status, right? The PNIC status, the connectivity to the management plane, the connectivity to the control plane, and so on, right? Giving us just further detail as to why we say this transport node is up and ready to be used. But once my transport node looks like this, we're ready to go. We can start building logical switches and start interconnecting virtual machines on these hypervisors in this cluster. Now, if we go back to the home page of NSX, we can monitor some of this. We can look at, from our system dashboard, remember we looked at this already, but we focused in on just the NSX nodes panel over there on the left that tells us about our managers. Here, if we spin just a little bit off to the right of that, we see our transport nodes dashboard, right? Same type of graph, right? These donut graphs. And these are giving us information about the configuration state of our different transport nodes, whether they're ESXi or edge nodes or so on. And I can click on any of those links and that'll take me in the UI to that type of object so that I can further investigate maybe if something is not right. On an ESXi host, I can log in and use the ESX CLI tooling to do things like show me all of the packages that are installed. ESX CLI software vib list lists out all of the vib packages that are installed on this ESXi hypervisor. Now, if I'm validating my NSX preparation, I don't want to see everything. If I pipe that output to the grep command, which is just a search command, and search for the term NSX, that'll just show me the NSX packages that have been installed, right? These should be there. For the most part, the versioning should match the versioning that I'm running for NSX. You'll notice here that some of them aren't quite the same, right? But I want to make sure that these packages are all here. So that's a quick validation. Now, let's go do this. Let's go prepare some transport nodes in our lab environment, right? So we're going to log back into the lab. We're going to build out a couple of transport zones, right? We're going to create a prod transport zone or a VLAN transport zone and an overlay transport zone. I said prod because the names of them are both prefaced with the string prod. So we're going to create 2 transport zones. We'll build out an IP address pool, and then we'll build a transport node profile, and then we'll prepare the transport nodes in our compute cluster. So that's what we're going to get into here in lab number 4. When you come back from lab number 4, we'll go ahead and wrap all this up. Okay. We built out our transport nodes. You should have 2 ESXi hosts in your compute cluster that are all prepared and ready to go. What did we do? We talked about everything that culminated in us building those transport nodes. We talked about our transport nodes and zones and our VDSs and NVDSs. We talked about IP pools. We built them in the lab. We talked about how to prepare those ESXi hosts. We talked about our VIBs and the installation, right? We talked about that whole process over the last couple of videos. And so that kind of wraps this one up. That's where we are on this. Now, we've got one more video in this specific series, in this module, and that's all going to be about DPU or SmartNIC configuration and utility with NSX. So that's really exciting. I can't wait to tell you about that here in just a few minutes.